right, here's a quick free response question and the solutions for it for this table with dealing with Riemann sums and integrals. So let's get right into it. Using the table, we want to estimate the number of people, how it was changing at time 5.5. Well, a couple things to look at here. First, we only want an estimate. We're not going to get an exact amount. And we're looking for a rate. So when I say rate, I'm thinking derivative. I'm thinking something with slope. Now, being at 5.5, notice there is no 5.5 here. However, I just want an estimate. And, well, the average from 4 to 7, that's time is 5.5. So what I'm going to be doing now is essentially taking a slope between these 2 points. So it's going to be 150 minus 126 over 7 minus 4. This is my rate of change that I want to know. So I do that subtraction, and I'll get 24 divided by 3, which means I'll have a solution of 8. Now they want to know units. Well, up top, we had people, and on the bottom, we were dividing by something in hours. So people per hour, that's how the rate is changing, 8 people per hour. All right? Moving forward, now we're looking into Riemann sums. They only want to know in here the first 4 hours. That's something pretty key here. So we're only looking up to this part. And they want 3 subintervals. So there's one interval, there's a second interval, and there's a third interval to look at. If we want to do first the left Riemann sum with 3 intervals there, what I'm going to do is, first, here's my first interval from 0 to 1. One's the width there, the width is 1. What is my left endpoint, because I want the left sum, it will be 120. My next interval has a width of 2, and my left endpoint is 156. And then the last one, my width again is 1, and my left endpoint is 176. So when I add those up and do the division, I should get 608 people. That's the complete sum. Now, this is what it is. This is like people times hours, because this is what we're doing here. This is the number of hours. This is the number of people. To find the average, I need to divide it by my 4 hours that they were there. So these were really, I guess we should call them people hours, if you want to be proper with the units. So I need to do that division, and I would get 152 people were averaged to be in line. Because again, the interval under it would be people times hours, so then divide hours to get rid of it. Now, for the right endpoint, same thing. My widths are going to be the exact same. My widths will be the same, but now for this first interval, I want the right endpoint. So my right endpoint here will be 156. My right endpoint for the second one will now be 176. And my right endpoint for the last interval is 126. So I add those up, I should get 634. My technical unit is people hours, if that makes any sense, for a unit. And then that means when I divide it by my 4 hours for the average, I should get 158.5 people. Now, if it asks for a approximation or an estimate, because that's what we're talking here, to estimate the average number of people in line, all you would do really would be say, well, for this one, 158.5 isn't bad. You don't want to say, you cut a person in half. Maybe say about 159 because you're rounding. Either way, though, these should be just fine for answers. All right, moving on to part C here. They want to know the fewest number of times where L prime must equal 0. Well, what does L prime mean? Well, that means that when is my derivative 0? When do I have a horizontal tangent? When do I go from increasing to decreasing or decreasing to increasing? Well, what I'm going to look at is each one of these intervals, what's happening. From 0 to 1, I'm increasing. I went from 120 to 156. The next interval, I'm still increasing. This interval here, I'm decreasing now. Up here, increasing, decreasing, and decreasing. L prime must equal 0 whenever I go from increasing to decreasing, or vice versa. Well, somewhere between 3 and 4, I'm going to have an L prime of 0 because I changed from increasing to decreasing. Same between 4 and 7, and same between 7 and 8. Now, it's not to say that, I went from decreasing to increasing. I could go a lot of times in here back and forth, But all I know for a fact is it's based on when was I increasing versus when was I decreasing. So the fewest number is 3 times because there were 3 intervals where you change from increasing to decreasing or from decreasing to increasing. That's the reasoning that you would need to give for that. And finally, this last part, at what the rate at which they were sold is given by this new equation. How many tickets were sold by 3 p.m.? Well, I'm given a rate. So to find a total number, I'm going to need to be doing an integral here. So an integral of R of t. And we want to know by 3 p.m. So that would be my total starting from 0, which was noon, to 3, which is 3 p.m. So now, the integral from 0 to 3 of R of t dt. This is not something that we know how to integrate yet. You could, it's not very pretty. I'll just leave it like that. So how would I do this integral? It's a calculator. All you need to do is plug this in and actually go and evaluate it. And when you do, you should get 972.8 tickets as your answer. And now they say round to the nearest whole number, so that just means 973 tickets were sold at 3 p.m. So there you have it. There is your free response question, and hopefully this should be good review for you leading up to the test.